This is my intermediate algebra course. Today we're going to continue to learn how to solve quadratic equations by completing the square. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now in the previous class we learned how to solve quadratic equations by completing the square, but the problems were pretty easy because we didn't really need to use this method. We could have actually used the factor method to solve those equations. And the reason that we started with those problems is that the arithmetic was pretty easy to deal with. But in this class, we're actually going to do quadratic equations where you actually have to use the completing the square method because the quadratic expressions are not factorable. So let's get to this, this class today. The first thing we're going to go over is why you, when completing the square, you divide the coefficient of x by 2 and then square the result. That's something that we didn't talk about. And we're not going to go over this a lot, but I just want to give you a general idea of why this works. So remember, to complete the square, you put the number that does not have an x on the other side, and you take the coefficient of x and you do two things to it. Number one, you divide it by 2, and number 2, you then square the result. So 6 divided by 2 is 3, then you have to square it and you get 9. So add 9 to both sides, and that makes this a perfect square. But you know, like I said, what we didn't talk about is why you take this number and divide by 2 and square it. Why does that complete the square? Well, that's what we're going to talk about a little bit now. So this expression here in purple is a perfect square, but it's a generic perfect square, and that's because this number here is not a specific number, it's just a. Now, we're going to take this perfect square and we're going to expand it. You know, just by the definition of square, that's just, you know, the number times itself. And then we're going to use FOIL, like we did in previous classes. To get this, we have F, O, I, and L of FOIL. And then notice the inner two terms are like terms. It doesn't matter if they're in the wrong order because the commutative rule of multiplication says that they're the same thing. So we add those two up and we get 2ax over here. Let me give a different color for that. So this is 2ax, this middle term here. And again, because we started with a perfect square over here, we know that this expression is a perfect square. And the a that you see in this expression is that special number that goes there. So what this tells us is that if we want to add a number to complete the square here, that number has to be the coefficient of x divided by 2 and then squared. Because if I take 2a and divide it by 2, I get a. That's this number over here. And then if I square it, that makes this expression, which is, again, a perfect square. So that's what this information tells us down here. In the blue, we have 2a, we divide it by 2, and then we square it to get the yellow. And, you know, you can read this if you want, but the most important thing that I want to tell you about all this on this page here, explaining why you divide by 2 and square, is that if I took a random sample of 1,000 students who know how to complete the square in any school system, I'd be shocked if 1 out of 1,000 could explain why that algorithm works, why we divide the coefficient of x by 2 and square it to complete the square. So you're not really required to know this information. I'm just giving you this explanation in case you're curious. So you can, you know, take a screenshot of that and look at that if you want. I would recommend that you do this, you know, after the class is done, because you don't want to spend all your time and energy looking at this. Again, you don't need to know this. This is just if you're curious why that works. So let's get into the first problems today. Again, the problems that we're going to do today are exactly the same problems that we did in the previous class, but they're just going to be more difficult in terms of the arithmetic. And these first problems are an example of that. In all the problems we did in the previous class, this number was even. So when you divide by 2, you just get a whole number. But with this problem, you can see that's not even. And I also want you to mention, I should mention that you can actually solve this particular equation by factoring. We're not going to get to the equations that you can't solve with factoring until, I think, problem number 5 or 6. Again, just to make the arithmetic a little easier. But because this is odd, the arithmetic on this problem is going to be a lot more involved than the quadratic equations that we did in the previous class. But just like we did in the previous class, you get that 18 and put it on the other side, and now we want to complete the square. We want to know what number do we add to both sides to complete the square. Well, you remember, you take this number and you divide it by 2, and then you square it. The problem is, if you divide that number by 2, you get a decimal, 4.5, or you can also write it as 4 1/2. But we're not going to write it in either of these different forms. The easiest way is actually just to leave it as 9/2. Yeah, you can. The numbers are just easier to deal with when you just leave it as 9/2. Because if you write 4.5 or 4 1/2, those numbers are actually written as sums. This is not a sum. 4.5, for example, is the same thing as 4 plus 1/2. And 4 1/2 is also just 4 plus 1/2. We don't want to write the number as a sum. That makes the calculations more difficult. So we're just going to leave it like that. But remember, you have to divide this number by 2, then you have to square it. Now, when you square that number, that's the same thing as just multiplying 2 fractions. And remember, when you multiply fractions, you just multiply straight across. 9 times 9 is 81, and 2 times 2 is 4. That is the number that we're going to add to both sides of the equation. And I know what you're thinking. You're thinking that, that seems horrible. I mean, we have to deal with all these fractions now? Well, yeah, you do. That's why completing the square is, again, the method itself you learned in the previous class is not that difficult. The difficulty is having to deal with the arithmetic. So this is a perfect square here, and I want you to understand very clearly that, I didn't mention this in the previous class because it wasn't really necessary, but now it's necessary. When you factor this expression, assuming this is a perfect square, and we know it is because we just completed the square, the number that goes here is always this number divided by 2. Again, I didn't mention that in the previous class because we didn't need to know it. But now it's really useful because the reason I'm telling you that is that this expression here is not easy to factor. Because, what two numbers multiply to 81/4 and add up to 9, that's not exactly intuitive. Of course, the number ends up being 9/2. 9/2 times 9/2 is 81/4, and 9/2 plus 9/2 is 9. But again, that's not intuitive. So for now on, when you factor this completed square, you just want to remember that this number is the coefficient of x divided by 2. And I know what you're thinking. You're thinking, that seems like a lot to remember. Well, that's why this method, completing the square, as I mentioned in the previous class, actually represents, kind of the climax of all your arithmetic and algebra. This is, what we're doing now is really the most important thing in all of K-12 mathematics. Okay, so now we're going to add these numbers together, but notice that one number is a whole number and the other number is a fraction. So how do we deal with that? Well, again, this is something that causes a lot of anxiety in students frequently. What we're going to have to do is we're going to have to get a common denominator, but before we do that, we're going to have to change 18 to a fraction. Remember, you can take any whole number and just write it as a fraction by putting 1 under the whole number. All right, so now, again, we want to get a common denominator, but now remember the fundamental principle of fractions. That tells you that you can multiply both sides of a fraction by the same number, or you can divide both sides of the fraction by the same number, and you get an equivalent fraction. So I'm going to multiply both sides by 4, and I get negative 72 over 4. And now you can see we have a common denominator. So we can add those two together. And over here, I'm just going to change that to power notation. And so adding those two fractions together, we get, because we have common denominators, we can just add the numerators. Negative 72 plus 81 is 9. And the denominator just stays the same. Again, that's just basic arithmetic. If you're a little rusty with this stuff, that's okay. But if you've never seen that stuff, that's probably not okay. Okay, so like in the previous class, this is all, the general procedure is the same exact procedure as the previous class. So we're doing a lot of, arithmetic, but the overall procedure is the same exact thing. So we need to get rid of that 2 power. So we have to do the opposite of squaring, which is square rooting. So then we're left with x plus 9/2 is equal to plus or minus. Now remember this principle. If you take the square root of a over b, you get the square root of a over the square root of b. We learned that in a previous class in this course. Well, we're going to have to use that here. So we get square root of 9 over square root of 4. And square root of 9 is 3, square root of 4 is 2. All right? So now we're just going to isolate x, subtract 9/2 from both sides, and one answer is going to be negative 9/2 plus 3/2, which is negative 6/2, which gives us negative 3. And the other answer is going to be negative 9/2 minus 3/2, which gives us negative 12/2, which is negative 6. And those are the 2 answers. So as you can see, that problem is pretty involved. Look at all this stuff. Look at all that math. That's why completing the square is considered to be the height of the K-12 math curriculum. There's really not much you're going to be doing that is more involved than this. Conceptually, you might be able to argue that some things are a little bit harder or more difficult to understand, but in terms of just the pure algebra and the arithmetic involved, which is really the most important part of the curriculum, it doesn't get much more involved than this. Okay, so now we're going to try another problem. Again, when you're completing the square, you just take the number that doesn't have an x and you put it on the other side. And now we're going to complete the square. So, like in the previous class, what you do is you just take that number, divide by 2, and we're just going to leave it as a fraction. And then you square it, and that's just negative 5/2 times negative 5/2. And again, that's just basic arithmetic. You just multiply straight across. Negative 5 times negative 5 is 25. 2 times 2 is 4. Now again, that's just, a lot of students, they don't like that. They say, well, where did that come from? Well, if you paid attention in my arithmetic course, if you took the course, if you passed the course, if you did what I told you to do in the course, if you finished all the homework, if you studied for the test and passed the tests, then, you might still be rusty on this, but it should be familiar, and it shouldn't be that intimidating to you. But if you've never seen it, then that's a problem. That means you probably didn't take my arithmetic course. Remember, arithmetic, pre-algebra, beginning algebra, and those 3 courses are prerequisites for this course. Okay, so now we'll go ahead and factor this because this is a perfect square over here. Now remember, it's extremely important to understand that this is not going to be easily factored. Okay, but you don't have to think about it. All you have to remember is that the number that you place here is always going to be this number divided by 2. Now again, you might think, well, how come you didn't tell me that in the previous class? Well, you didn't need to know. Now you need to know, because now this expression is not easily factored anymore. So now we're going to add these terms, but remember, in order to add a whole number with a fraction, you have to get a common denominator. So we have to turn this number into a fraction. And any whole number can just be written as over 1. So now we're going to multiply both sides of this. Well, first of all, let's go ahead and combine this, the right side, to power notation. And we're going to multiply both sides of this fraction by 4, and that gives us 200 over 4 plus 25 over 4. And now we've got a common denominator over here, so we can add those up. And I should probably put a divider. So 200 plus 25 is 225. And now we can, square root both sides. And remember that principle. I'm going to bring it down just so you can remember. We learned that in a previous class. Whenever you square root a fraction, it's the same thing as square rooting the numerator and the denominator, so that becomes plus or minus square root 225 over square root 4. And the square root of 225 is 15. And the square root of 4 is 2. And now we're going to add 5 halves to both sides. And we get 5 halves plus or minus 15 over 2. And so x can be 5 halves plus 15 over 2, which is 20 halves, which reduces to 10. Or x can be 5 halves minus 15 over 2, which is negative 10 over 2, which is negative 5. So, yeah, again, in these problems, you could actually factor. The factoring method still works. I said that we're going to solve equations where you cannot factor very easily, but so far we're starting off with ones where you can factor. The only difference is that these coefficients of x are now odd, so that the math is a lot more difficult. Okay, so we're going to do one more of these together, and I want you to understand very clearly that you really, really, really need to pay attention to what we're doing. Because as you notice, this is a pretty complex process here. There's a lot going on here. And so if you don't pay attention to what we're doing in these first 3 problems, we did problem 1 and 2, and now we're doing the 3rd problem, and you're going to try number 4 yourself. If you don't pay attention to what we're doing here, it's really easy to just get completely lost. Because there's so much going on here. We have to deal with a fraction. We're taking 9 halves, or dividing 9 by 2, leaving it as a fraction 9 halves, and then squaring it to get a fraction here. And then when we factor this, that's not easy. We have to take this number, divide it by 2, and put it there. And then we have to remember that that's always the way it works. And we have to add negative 18 plus 81 over 4 by getting a common denominator, so on and so forth. We have to remember the square root of a fraction is the square root of the numerator over the square root of the denominator. There's so many things happening here. And if you don't pay attention to what's happening here, again, you're just going to get completely lost. Again, this represents the height of the math curriculum in the K-12 school system. So let's go ahead and try one more of these. But as we do this problem, again, you really need to keep in mind that you have to pay attention to what we're doing, or else when you try number 4, the first problem you're going to do on your own, you're going to be just completely lost. So we're going to take the 12 and put it on the other side, like we did in the previous class, but now we have to complete the square. And remember, the coefficient of x, that tells us how to complete the square. So we take that coefficient of x and we do 2 things. We divide by 2, and then the next step is we take that and we square it. And negative 7 over 2 times negative 7 over 2 gives us 49 over 4. So 49 over 4 is the number that we're going to use to complete the square. So we're going to add that to both sides. And now we just completed the square. So now remember, this is one of the things that you really need to keep in mind, other than the fact that, all that stuff about, changing the 7 to a fraction, and this number doesn't change at all. We're just using that number to figure out what we add. That's a problem that a lot of students have, is they take this and they start dividing by 2. Well, we're not dividing that by 2. We're doing nothing with this number. All we're doing is using this number to see what we're going to add on both sides. That's extremely important. So we divided 7 by 2 and we squared it. You have to remember, to keep it as a fraction, and you have to know how to multiply fractions. You also have to know that, factoring this is not easy, so you're always going to write this number divided by 2 in the product of these binomials. You always do it that way. You're going to have to know that for problem number 4. Don't forget that. You're also going to have to know that you're going to take a whole number, change it into a fraction, because you have to add the whole number with a fraction. And you're going to have to remember the fundamental principle of fractions, which, I shouldn't have to tell you by now. You can multiply both sides of a fraction by the same number, and the fraction remains equivalent. And so now you have a common denominator. So now we're going to change that to power notation. And we're going to add those fractions together, and we get 1/4. And we're going to square root both sides to get rid of that square. So we get x minus 7/2 is equal to plus or minus, and remember this principle here. I'm going to bring that down. Again, you should know that without me having to bring that, formula down there. But I just want you to remind you where that comes from. You square root the numerator and you square root the denominator. Now the square root of 1, that's just going to be 1. And the square root of 4 is 2. All right, so now we're going to add 7/2 to both sides. And again, you can put the 7/2 on the right or the left of the 1/2. It doesn't really matter. And so now x can be 7/2 plus 1/2, which is 8/2, which reduces to 4. Excuse my voice. And x can be 7/2 minus 1/2, which is 6/2, which is 3. And there you go. Again, apologize for my voice. Okay, so that's a lot going on there, and you can take screenshots of these two problems if you'd like, and you can take screenshots or a screenshot of this problem if you'd like. But again, I have to tell you, these problems they're involved. If you didn't pay attention to all that, then there's no way you're going to be able to do problem number 4. So, if you get stuck, that's okay, but don't just give up. You have to go back to the previous problems and make sure that you, figure out how to do each step, because we're using a lot of math here. So go ahead and try number 4. Remember, the first step is you're going to move the 8 on the other side. And also, remember, this is an odd number. So what that means is when you try to complete the square, you divide that by 2, you're going to get a fraction. And then you have to square a fraction to figure out which number, like this number over here, you're going to have to figure out you're going to have to square the fraction to figure out which number you add to complete the square. So a lot going on there. So try number 4, and when you come back, we'll do it together. All right, we're back. And I put the 8 on the other side. Now we're going to complete the square. We have to take this number, the coefficient of x, and do 2 things to it, just like we did in the previous class. We divide it by 2, and then we square it. And if you do that, you get 81/4. So we're going to add 81/4 to both sides of the equation. and that completes the square. So now we have, and again, remember, when you factor the binomial, it's always going to be equal to this number divided by 2. That's where we get these numbers. It's going to be, every single time you do it, it's going to be that coefficient of x divided by 2. So again, why did I not tell you that in the previous class? Well, because you didn't really need it in the previous class. It just would have complicated things. But now you need it, because it's not easy to factor this expression. Even though it's a perfect square, it's still not easy because you have a fraction there. Okay, so now we have to combine these two, but we can't do that unless we get a common denominator, and we can't get a common denominator unless this 8 looks like some sort of a fraction. So remember, you can always write a whole number as over 1. So that's 8 over 1. I want to move this over a little bit. So now we're going to multiply both sides of this fraction by 4. And then we get 32 over 4. Changing that to power notation. 81 over 4 minus 32 over 4. That's going to be 49 over 4. And now we're just going to square root both sides of the equation, just like we did in the previous class. And remember this green principle up here. When you square root a fraction, you just square root the numerator and you square root the denominator. So that would be square root 49 over square root 4. All right, so square root of 49, that's just going to be 7, of course, and square root of 4 is going to be 2. And then we're going to subtract 9 from both sides. And now we're ready to separate. So x can be negative 9/2 plus 7/2, which is negative 1, reduces to negative 1. Or it can be negative 9/2 minus 7/2, which is negative 16/2, which gives us negative 8. So if you got those answers and you use the completing the square method, good job. Again, if you're thinking that this is very involved, you're right. This is very, very, very involved. Completing the square, I said it twice already. I'll say it again. Completing the square represents the height of your algebra and arithmetic curriculum in the school system. So, again, you can take screenshots of these two pages if you want to help you do the next problem. And so go ahead and attempt number 5. Remember, you got to get that 2 on the other side. That's the first step. And then you have to take this odd number, divide by 2, but it's going to be, a fraction. You're going to have to deal with a fraction. You're going to then have to square the fraction. Try number 5, and when you come back, we'll do it together. All right, we're back. So we're going to put the 2 on the other side. And then we're going to complete the square. And that's going to be 9 over 4. 3 over 2 divided by 2. Then square it, just like we did in the previous class, except now we're dealing with fractions. Okay, so this is a perfect square over here as usual, but it's really hard to see how to factor that, but that's okay because like I told you, it's always this number divided by 2 here. Okay, and then we have to combine these, so we have to turn 2 into a fraction. And multiply both sides of this fraction by 4. And we get 8 over 4. as usual, change that to power notation. And 9 over 4 minus 8 over 4 is 1 over 4. And at this point, you notice we're out of room, but don't panic if that happens. If you're out of room, all you have to do is take an arrow and go up here. And at this point, I'm going to erase this. I think you get the point there. We don't really need to dragging that. We don't need to keep dragging that around. So now we go up here, and we're going to take the square root of both sides. And we get plus or minus square root 1 over square root 4, which equals x minus 3/2. And square root of 1 is 1. Square root of 4 is 2. And then we're going to add 3/2 to both sides, and we get 3/2 plus or minus 1/2. And then we can separate, and we get x is equal to 3/2 plus 1/2, which is 2, or 3/2 minus 1/2, which is 1. And those are the two solutions. So if you got those answers, good job. Okay, so those first 5 problems that we did were problems where you could actually factor those problems. They were not problems where you had to use the completing the square method. And we started with those problems just because they were a little easier. But again, the difficulty was that this number is an odd number. In the previous classes, all these numbers, these coefficients of x, were even. So it made the math really easy. So that was the difference with those problems. Now we're going to problems where the coefficient of x is now even again, so that's going to make it a little easier. But what's different about these problems is that you cannot factor these problems easily at all. Okay, if you tried to factor this problem, that would be, that would take some advanced math. Okay, so we have to use completing the square in order to do this problem. We have no choice. But that's okay because we know how to complete the square, so let's get started. We're going to put the 1 on the other side as usual. And by the way, if you cannot factor a quadratic equation, what that means is we're going to get answers that are called irrational numbers. We haven't talked about this in my curriculum yet, but a lot of people think that this is, it's not really super important unless you're taking some sort of a test that requires you to know the definition. But a rational number is any number that can be written as a fraction. For example, 5/6 is a rational number because you can obviously write it as a fraction. The number 2 is a rational number because you can write it as 2 over 1. Any number that can be written as a fraction with integer numerator and denominator is called a rational number. Now, an example of an irrational number would be like square root 3. That's not rational because what you'll find is that that's a non-terminating, non-repeating decimal. And you're probably thinking, what in the world does that mean? Well, if you go to your calculator and you plug in 3 and the square root button, you get 1.732050807, and it just keeps going on and on and on and on. So if it goes on and on and on and on, and it doesn't repeat. Notice there's no repeating pattern here. Okay, after the 7, it doesn't repeat. It just goes to 5, 6, 8, 8. There's no repeating. If it keeps going on forever and it does not repeat, that is an irrational number, because it is true that you can write, this as 7/10 plus 3 1/100 plus 2 1,000ths. You can write a bunch of fractions. And if the decimal stopped there, if it stopped at the 2, then you could actually combine all these and make a fraction. The problem is because it never stops and it never repeats, how are you going to combine these to make a fraction? You can't do it. So that's why root 3 is considered to be an irrational number. I know that seems kind of complicated, but all you have to know is whenever you see the root of a number that's not a perfect square, for example, like root 8 or root 10 or root 18, these are all irrational numbers because they're not perfect squares. If you find the root of 9, well, that's a rational number because that's just 3. You can write that as over 1. Again, anything you can write as a fraction is a rational number. So again, if you cannot factor a quadratic equation easily, then that means you're going to have probably square root answers. And that's what you're going to see here. Another example of an irrational number would be pi. You know, we went over pi. That's a non-repeating decimal. It just goes on and on. And also, I forgot to mention, be aware that if you take a number like 1/3, that's a rational number, but that number does it is non-terminating. So it's not enough for it to be non-terminating to make it an irrational number. It has to be non-terminating and non-repeating. Just be aware of that. We'll talk more about that probably later on in this course. But so now we're going to complete the square. Divide by 2 and square it, and you get 4. So we're adding 4 to both sides, and that's a perfect square. You can actually factor that just by figuring out what two numbers multiply to 4 and add up to 4. But like I said at the beginning of this class, it's always going to be this number divided by 2. You don't really have to even think about it. Okay, so now we get x plus 2 squared is equal to 3. And if we square root both sides of the equation, it's very important to understand that this square root, we can't do anything with that. You know, it doesn't simplify to a whole number. So, that's why we couldn't factor this problem. Now we just subtract 2 from both sides and we get negative 2 plus or minus root 3. That's the answer. In case you're wondering, that's why we couldn't factor this expression up here, is because, whoops, sorry, my computer's jumping around there. That's why we couldn't factor this expression up here very easily, because the answers had square roots. So there's two answers to this. There's negative 2 plus root 3, and there's negative 2 minus root 3. But they both have root 3's, and so that's what makes it to where it's not easy to factor that expression. Okay, so I want you to try number 7. It's going to be the same type of problem. But again, because these numbers here are even, you see how these numbers here are even? That makes it to where the math is really not that difficult. So try number 7, and when you come back, we'll do it together. All right, we're back. So I'm going to put 2 on the other side. And, we're going to complete the square just like we did in the previous class. Divide 6 by 2 and square it, and you get 9. And then we get 11 is equal to, you can always divide that number 6 by 2. Then you get 3. Or you can just figure out what two numbers multiply to 9 and add up to 6. Then change it to power notation. And now we want to square root both sides of the equation. And we get plus or minus square root 11 is equal to x plus 3. Subtract 3 from both sides, and we get negative 3 plus or minus square root 11. So if you got those answers, good job. Again, there's two answers, negative 3 plus root 11 and negative 3 minus root 11. So those were the first two problems, or the first two quadratic equations that we did in this course, where you could not solve simply by factoring. Okay. And in case you forgot what factoring is, just to give you an example, you might have something like this. We can solve that by factoring, just like we did in the previous class. X plus 4 and x plus 5. 4 times 5 is 20, and 4 plus 5 is 9. So once we factor it, we can see what the solutions are going to be. The solution is, they're going to be x is equal to the opposite sign, -4, or x is equal to the opposite sign, -5. You know, whatever the signs are in here, the answers are going to be opposite. So that's the factoring method. The previous two problems we did, you know, we can't we can't use that method. It's not easily factored. Okay, so let's try the next problem here. Let's do this one together. Now here's a problem where the coefficient of x is odd. The coefficient is 1 because you don't see it there, so that's going to make things a little more difficult. And also, what you'll notice is that we can't factor this expression. So this is another equation where you have to use the method of completing the square. You know, and nothing else works. So let's go ahead and do that. So these problems are just going to get kind of more and more involved as we go into as we continue with the problems. So now we're going to take the coefficient of x, which is 1, and we're going to divide it by 2, and then we're going to square that, and we get 1 over 4. And that's what we're going to add to both sides of the equation to complete the square. Okay, so now the left side of the equation is now a perfect square. And remember, it's always this number divided by 2. Whoops. And then we're going to have to write that as 3 over 1 plus 1 over 4. Multiply both sides of 3 over 1 by 4. And we get 12 over 4 plus 1 over 4. Change this into power notation. And then we get 13 over 4 is equal to the following. And of course we have to square root both sides. Remember to put your plus or minus. Students always forget to put that plus and minus sign. Plus or minus sign. And then we're going to have to use that principle where we square root the numerator and the denominator. But the difference here is now, you know, the numerator is not a perfect square. So we can't do anything with the square root of 13. That's why this problem, the quadratic expression, is not easily factorable, because the solution has what you call an irrational number in it. Root 13 is an irrational number. So now, sorry, I'm just spacing out the work. So now we can separate. One answer is, actually no, I'm sorry, we don't need to separate this. We can just leave it like that. That's the best way to, actually, you know what? We have common denominators, I'm sorry. If you have a common denominator, then you can go ahead and just add those together. So we end up with -1 plus or minus root 13 all over 2. Again, now why could we do that? Well, remember, if you have fractions with common denominator, you can just add those fractions together. You know, some textbooks might consider this to be the answer. I would go ahead and add it together so you have one fraction. Okay, so let's try one more of those problems before you try one on your own. I make a divider. Put the 8 on the other side. We're just following the same procedure we did in the previous class. No big deal. Take 5 divided by 2, square it, and you get 25 over 4. And the right side, we completed the square now, so now it's a perfect square. Now, how do we factor that thing? Well, remember, it's just the coefficient of x, -5, divided by 2. And we have 25 over 4 plus 8 over 1. Multiply both sides of this fraction by 4 and we get 32 over 4. We can write this in power notation as usual. 32 plus 25 is 57. And then we're going to square root both sides. And remember, you can use that principle where you square root the numerator and the denominator. So we have plus or minus square root 57 over 2. Add 5 halves to both sides to isolate the x, and we have 5 halves plus or minus root 57 over 2. And we have a common denominator, so we can add those together, and we get 5 plus or minus root 57 all over 2. Okay, now it's time for you to try. Again, the difficulty of these problems, and you can take screenshots of those too, I would suggest that you do that. The difficulty of these problems is that not only are the answers going to be irrational, meaning you're going to have roots in your answers, not only can these expressions not be factored very easily, but also you have an odd number here, so it's getting them a lot more difficult with these problems. So go ahead and try number 10. And again, when you complete the square, the first step is you take that 1 and put it on the other side. And then you're going to have to take this number, divide by 2 squared, just like you did on the previous class. So go ahead and try number 10, and when you come back, we'll do it together. All right, we're back. Three divided by 2, and then square it, and you get 9 over 4. That completes the square. Remember, when you factor, it's always this number divided by 2. When you factor to a product of binomials. And then we have negative 1 over 1 plus 9 over 4. You don't have to show all of this stuff if you don't want to. And you don't even have to show this if you don't want to. You can just go straight to x plus 3 halves squared. And you can combine this in your head if you really want to. In fact, that's what you really should be doing. Multiply both sides of this by 4, and we get negative 4 over 4 plus 9 over 4. And the reason that you should be skipping ahead is because obviously this is going to get really tedious if you have to do this every single time. If you feel that you need to do it, that's completely fine. Just be aware that the problems are going to take longer. And eventually you're going to get pretty sick of just doing problems that take forever. The reason I'm showing the steps is I want you to see exactly what we're doing, just in case you feel that you need to see it. And again, this is math that is the height of the entire K-12 math curriculum, so this is not easy stuff. Square root 5 over square root 4. That's another thing that you don't really have to show. Now we're going to subtract 3 halves from both sides, and we get negative 3 halves plus or minus root 5 over 2. And we're going to put those together, negative 3 plus or minus root 5 all over 2. And that is the final answer. So if you got that answer, good job. If you got stuck in a few steps, that's okay. But now you know how to do it. Go back and figure out what you did wrong. Okay, on to number 11. I'm going to leave that in the window. In fact, I'm going to leave all these problems in the window. Go ahead and try number 11. And when you come back, we'll do it together. Again, we're using the method where we complete the square. All right, we're back. Put the 4 on the other side as usual. And we're going to have to complete the square. Divide 7 by 2, square it, you get 49 over 4. I'll move this over a little bit. And we get 7 over 2. And again, it's always this number divided by 2 that goes in the product of the binomials to complete the square. Multiply both sides by 4. And we get 16 over 4. Change to power notation. 49 plus 16 is 65. And of course, we're going to square root both sides. And we get plus or minus square root 65 over square root 4. And then we're going to add 7/2 to both sides. Actually, we should probably simplify that first. And then add 7/2 to both sides. We get 7/2 plus or minus square root 65 over 2. And then we have a common denominator, so we can go ahead and combine those. And we have 7 plus or minus square root 65 all over 2. So if you got those solutions, good job. And the reason I say solutions is because there's 2 of them. There's 7 plus root 65 over 2, and there's 7 minus root 65 over 2. All right, so on to number 12. Now for these problems, notice we have something we didn't have in the previous problems. Now we have a coefficient in front of the x squared. So these problems are getting even more difficult. So let's do this first problem together. Now, I mentioned in the previous class that you cannot complete the square in a quadratic equation if there's a coefficient on the x squared term, at least in 99% of the cases. So what you have to do first, you have to get rid of this coefficient on the x squared term. So just like we did in the previous class, we're going to divide both sides of the equation by 2, and then we get x squared plus 2x minus 3 over 2 equals 0. And we can't really do anything with that. We just have to leave it as a fraction. So now we're going to complete the square just like we did in previous problems. We're going to take that number, put it on the other side. And again, to complete the square, we're going to take this number, divide by 2, and then square it. So 2 divided by 2 is just 1. And then 1 squared, of course, is just 1. So we're going to add 1 to both sides of the equation. So that made it to where it's, that was something that was actually easy about this problem, because this coefficient was actually even. So we don't have to deal with the fraction here. That's good. Okay, so this is now a perfect square because we completed the square. And you can factor that pretty easy. What two numbers multiply to 1 and add up to 2? But again, you don't really have to do it that way. You can just take this number, divide by 2, and it always works when you're completing the square. And And so we're going to change that to power notation. And, I'm just going to write this 1. I'm going to write that as 1 over 1. Multiply both sides by 2, and we get 2 over 2. Add those two together, and we get 5 over 2 is equal to x plus 1 squared. And just the same procedure. Square root both sides. Make sure to put your plus or minus. It's so easy for students to forget that plus or minus. So now something new is going to happen. Now we have a fraction where neither of these numbers in the fraction are perfect squares. So we're just going to have square root 5 over square root 2. And by the way, the problem here, you might think, well, how come we can't just leave it like this? Well, we learned in my previous classes in this course that the problem is you have a square root in the denominator. You can see when we change it to this form, there's a square root in the denominator. Mathematicians don't like that because that makes division of difficult when you have a divisor that is an irrational number. So actually before we put the 1 on the other side, so at this point we need to rationalize that denominator. Okay. And the way we do that is just multiply both sides by root 2, just like we did in the previous classes. And I can't show every single step. So we're going to have to skip forward with this stuff, but you should already know this stuff. This just becomes the square root of 5 times 2 on the top, which is 10, you see. And in the bottom, we have the square root of 2 times 2, which would be 4. But the square root of 4 is just 2. So in the bottom, we're just going to have 2, you see. So we don't have room to show all those steps. And, at this point, we really don't have, you're getting to a point where we're going to have to be able to do that without showing every single step. Okay, so now the final answer is going to be -1 plus or minus root 10 over 2. Okay, let's put a divider and try the next problem. So again, what's different about these problems is that we have a coefficient on the x squared term. We have to get rid of that. You cannot complete the square. That's one of the most important points today. You cannot complete the square if you have that coefficient there. So we're going to have to divide both sides of the equation by 4 to get rid of that coefficient of the x squared term. And you might be thinking to yourself, this is a lot to remember, and you're right. It's a lot to remember. But that's why this is intermediate algebra. This is not beginning algebra. This is intermediate algebra. So things are going to get more difficult. But it's nothing that you can't handle. All right, so we're going to take the 5/4 and put it on the other side. By the way, the only reason that you couldn't handle this stuff is if you didn't fulfill the prerequisite courses and you didn't do, the things that I told you to do in my previous courses. Remember, you have to do all that homework and take the test and pass the test, or else you're not really ready for this course. Let's see here. So now we're going to, at that point, it's just a normal type of problem. We take the 5/4, put it on the other side, and we're ready to complete the square. Again, I'm showing a lot of steps that you don't really need to show. I'm just doing this for your benefit. So we take 10 and divide it by 2, and we get -5, and then square that, and we get 25. So that's good that we got, a whole number. We didn't have to deal with the fraction there when we completed the square. And this is very easy to factor, but again, it's always just this number divided by 2 whenever you have a perfect square. We're going to write 25 over 1. Actually, I'll write that down here. Multiply both sides of this fraction by 4, and we get 100 over 4. get 95 over 4 is equal to x minus 5 squared. And of course, we're going to have to square root both sides to get rid of that square. And we end up with x minus 5 is equal to plus or minus the square root of 95 over the square root of 4. And 95 we can't really do anything with, but the square root of 4, that's going to be 2. And by the way, you can put the plus or minus here. You can put it, it's probably best to put it so it's level with the fraction line. And the final answer, x is equal to 5 plus or minus the square root of 95 over 2. Okay, so now it's time for you to try one of those problems. I'm going to go ahead and leave those in the window. And I want you to try number 14. Now, please understand, you need to get rid of that coefficient first. You cannot complete the square with a coefficient on the x squared term. So go ahead and try number 14, leaving those other problems in the window, and when you come back, we'll do it together. All right, we're back. So we have to get rid of that negative 3 and the coefficient of x squared. We cannot have a coefficient of x squared if we're going to complete the square. Sometimes you can, but those examples are just not even worth going over because they're so rare. That looks right. So now we got rid of that coefficient, and we're just going to solve like we usually do. And we're going to complete the square. So remember, 6 tells us, the negative 6 tells us how to complete the square. Divide negative 6 by 2, you get 3, negative 3, and then square that, you get 9. So we're going to add 9 to both sides. And factor that, and we have x minus 3, x minus 3. That becomes 9 over 1. Again, you don't have to show all this math here. You can just add these two together in your head and get the answer immediately. Multiply both sides of this fraction by 3, and we get 27 over 3 plus 4 thirds is equal to x minus 3 squared. 27 plus 4 is 31. So then we're going to square root both sides. As usual. And we're going to use, again, this principle, square root of a over b is equal to square root of a over square root of b. And now we have, and again, we can't leave it like this because there's a root in the denominator. And so we're going to have to multiply both sides by square root 3. And I'm just using a different color to show that we're doing something important to rationalize the denominator. So now we're going to use this principle, root a times root b is equal to root ab. So that would be root 3 times 31 is 93. And in the bottom we're just left with 3. And let's see here, let's see if we can make some more room. There we go. Keep your plus or minus symbol. And finally, x is equal to 3 plus or minus root 93 over 3. And there you go. All right, so go ahead and try number 15, and I'll keep number 14 in the window. Remember, you need to get rid of that coefficient of x squared, divide both sides by 9 first. So try number 15, and when you come back, we'll do it together. All right, we're back. So first step is to get rid of the 9. And I'm just showing that in green so you know how important that first step is. And now we can just do the same method, the same steps that we did in previous problems. And we're going to complete the square, so we take 4 divided by 2, you get 2, and then square 2 and you get 4, so we're going to add 4 to both sides. So the reason we did that is because now we have a perfect square. We can factor that easy. What two numbers multiply to 4 and add up to 4? Well, it's 2 and 2. But again, you could just take this number and divide by 2. That gives you the answer every time. So we gotta have negative 2 ninths plus 4 over 1. Multiply both sides of this fraction by 9, and you get 36 over 9. Negative 2 plus 36 is 34. And we're going to square root both sides as usual. And we have x plus 2 is equal to plus or minus square root 34 over square root 9. And square root 34 over 3. And the final answer is negative 2 plus or minus square root 34 over 3. And there you go. So if you got that answer, it's very good. Good job. In this problem, we didn't have to complete the square. Or excuse me, we didn't, of course we had to complete the square. We didn't have to rationalize the denominator. Over here, you see what we did here? We had to rationalize the denominator because we had an irrational number there. But here, you know, we didn't have to worry about that because 9 was a perfect square. So we just got 3 in the denominator. So again, if you got that answer, good job. If you made a mistake, that's okay. Just go back and figure out what you did wrong. Okay, these are basically the same types of problems, but when we square root the fraction, something different is going to happen. Nothing you haven't seen already, though. So we need to, again, get rid of that coefficient first. We cannot complete the square with that coefficient of x squared. And now we're going to put the 1/5 on the other side as usual and complete the square. And so we're going to take 8, divide it by 2, and then square it, and we get 16. And that's a perfect square. We can easily factor that, but also remember it's just this number divided by 2 goes here. And then we have 1/5 plus 16 over 1. Multiply both sides of this by 5, and you get 80 over 5. And add it together and you get 81 over 5. And then this is a part that's going to be a little bit different. We haven't seen this yet today, but you have seen it in previous classes in this course. We're left with x minus 4 is equal to plus or minus square root 81 over square root 5. So the numerator is a perfect square. So we're just going to end up with 9 over square root 5. But now we have a problem. The denominator is irrational, so we need to rationalize the denominator. And so I'm going to go ahead and rewrite. And again, we need to, we can't show every single step because it would just be too tedious. So I'm going to multiply both sides by root 5. Why do we want to do that? Well, it's just going to get rid of the root in the denominator. So now we have x minus 4 is equal to plus or minus 9 root 5 over 5. And let me move this up a little bit to make some more room. Final solution would be 4 plus or minus 9 root 5 over 5. So again, the only difference with that problem is we had an irrational root in the denominator, but the numerator, we had a perfect square. So go ahead and try number 17. Remember, you have to get rid of that coefficient, that negative 6 first, or else you cannot complete the square. So try 17, and when you come back, we'll do it together. All right, we're back. Get rid of the coefficient. And then we're going to take 2 divided by 2 and then square it, and now we get 1. That completes the square. Now we've got a perfect square over here. (19 over 6 plus 1 over 1). Multiply both sides of that fraction by 6, and we get 6 over 6. Now we can add those together, combine this into power notation, and we get 25 over 6. And then we're going to square root both sides. And then we get x plus 1 is equal to the square root of 25 over the square root of 6, just using that same principle that we've used so many times before. And x plus 1 is equal to plus or minus 5 over root 6. But now we have a problem. The problem is the denominator has a root in it. Remember, we're not allowed to have a denominator inside the root. So we just move that up a little bit. So we're going to have to multiply both sides of the fraction by root 6 to get rid of that root in the denominator. And let me just move this up a little bit. And then we get x plus 1 is equal to plus or minus 5 root 6 over 6. And now we just have to write the final answer. Sorry, I'm kind of running out of room here. And the final answer is negative 1 plus or minus 5 root 6 over 6. All right, so if you got that answer, good job. All right, on to number 18. So for number 18, we're getting a little bit more difficult, looks like. Let's try this one together. And each one of these problems, something different happens. There's a slight different, it's a different variation. There's so many types of these problems that you can attempt. And as usual, we're going to take the 8/3 and put it on the other side. And then we're going to complete the square. Take 7 divided by 2 and square it, and you get 49/4. So this problem, we have a lot of fractions. That's a perfect square, which means this is going to be x minus 7/2. Now, how did I know it's going to be x minus 7/2? Well, because when you're completing the square, it's always this number divided by 2 that goes in here. I know I keep saying that like a broken record, but it's so important for you to understand that, or else you're going to have a lot of problems with the homework. So now we have to add these fractions, and that's going to take something a little bit different. These denominators are different, so we're going to have to multiply both sides of this fraction by 4 and both sides of this fraction by 3. And that's going to give us, looks like 147. And then we just have to, again, put this in a power notation as usual. And 147 minus 32, that's going to be 115 over 12. And following the same process, again, this is all the same general process. Square root both sides. And probably going to have to move this. So then we get x minus 7/2 equals plus or minus root 115 over root 12. So the difference with this problem is now we have two problems. One problem is we have a perfect square factor inside that root, and the other problem is we have a root in the denominator, so we're going to have to take care of both those problems. Again, this is all review from my previous courses. So first thing we're going to do is take care of the perfect square problem, and 12 is 4 times 3, and so we can factor that to the 4. I'll just factor it to root 4 times root 3. We don't have time to show every step, like I said before. We don't really have enough room on the page to even show every single step. So you're expected to really skip some of these steps. So we have 2 root 3. And then at that point, we can multiply both sides of the equation by root 3 to get rid of that root in the denominator. And we have x minus 7/2 is equal to plus or minus 3 times 150 would be 345. And then you end up with 2 times 3, because root 3 times root 3 is just 3. And then we have x minus 7/2 is equal to plus or minus, let me get some room here, and then finally we have x is equal to 7/2 plus or minus root 345 over 6. And we could get a common denominator if we wanted to, but we don't really need to. So it looks like that's going to be it. So again, the difference with that problem is that we had a perfect square in the denominator, or we had to do a perfect square factor in the denominator. We had to get rid of that, and we had to get rid of the root in the denominator. So number 19 is going to be a similar problem. Go ahead and try number 19, and when you come back, we'll do it together. All right, we're back. So as usual, the first thing we need to do is get rid of that coefficient on the x squared term. And we're going to take the 10/7 and put it on the other side. And 5 divided by 2, and then square it, you get 25/4. I'm going to move that over. So we completed the square over here, and we have x plus 5/2 times x plus 5/2. And how did I know 5/2? Because it's always this number divided by 2. Very important. Now, we have to multiply both sides of this fraction by 7, and that gives us, looks like it would be 175/28. And you can use the calculator for that. Multiply both sides of this fraction by 4, and we get 40/28. And you might be thinking, well, how come we did that? Why did we multiply, in that particular way? Well, it's pretty obvious, isn't it? We used the fundamental principle of fractions, and we got the common denominator. I mean, that's why you do that. So now we're going to add those together, and we get 215, it looks like, over 28. And so now we're going to square root both sides. Don't forget your plus and minus, plus or minus. And factor the that's 4 times 7, and you break it into parts. And again, if I didn't mention, that would be square root a times b is equal to square root a times square root b. I guess I don't really have the room there. Square root a times b is equal to square root a times square root b. That's the principle we're using there. It's all stuff that we've done in previous classes. So square root 4 times square root 7. Again, we don't have the room to show all the steps there. And that's just going to be root 215 over 2 root 7. But now the problem is we have a root in the denominator. So we have to get rid of that root. So we're going to multiply both sides of that fraction by root 7. And we're getting some big numbers here. I'm going to have to shrink this. So now we get, you can use your calculator for that. 215 times 7 is 1,505. Over 2 times 7. Because root 7 times root 7 is just 7. And, we really don't have, a lot of room to show all this. This is the reason, one of the reasons that you need to learn how to go forward with all this stuff without really showing every single step. So now we're going to put the 5/2 on the other side and combine the 2 and the 7, and we get 14, and we're done. So if you got that answer, good job. Okay, that was the class today. If you want to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. This is screenshot number 1 and screenshot number 2 and screenshot number 3 And screenshot number 4. And screenshot number 5. But don't go before you get your homework. Let's take a look at the homework. So here's the first 2 pages, or the only 2 pages of the homework. Remember, your homework has to have those 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. And remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So go ahead and get that homework done, and I'll look forward to seeing you in the next class.